In this video, we're going to talk about transformation of functions, and we're going to focus on horizontal transformations that involve the x-coordinate. So we're going to be talking about what's going on inside the parentheses. We're not going to focus too much on the transformations of the y-coordinate, which recall would involve the a and the d. We're going to focus on the b and the c. Now, folks, it's so important when you're looking at the horizontal transformations to decide whether you are in non-factored form, like we are on the left, versus factored form, like we are on the right. You could see on the right, the GCF has been pulled out. You see two sets of parentheses. That's important. Two sets of parentheses means you're in factored form. One set of parentheses means you're in not factored form. It turns out that this distinction will determine the order of operations that you perform. Specifically, if you are in non-factored form, you're going to use reverse PEMDAS, and you're going to focus on this horizontal shift to the left, to the right 2 units, and then the horizontal compression with a factor of 1/2. So this is first and this is second. In the factored form, we're going to focus on the horizontal compression of a factor of 1/2 first, and then we're going to talk about the horizontal shift 1 unit to the right second. All right, so notice the amount that you're shifting changes based on whether you're doing it first or second. Let's first look at this non-factored form. Recall, when you're dealing with the non-factored form, there's only one set of parentheses. We're going to deal with this first and that second. Okay, so here we go. We're told that on f of x we have a point 4, 2, and we're asked to find the new point x prime comma y prime on this transformed function. Okay, so let's look at the x first. Recall that the x prime is going to be the x original divided by your b value and then the opposite of the c value. However, the question is, which of these do you do first? And again, in the non-factored form, we're going to do the c first, then the b. Okay, so our original x equals 4. X prime is going to be our original x, which is 4. Opposite of c, which is plus 2, gives us 6. And then we're going to divide by b, which is 2. And we're going to get x prime equals 3. Okay, let me write that over here. Okay, now for the y-coordinate, recall the y-coordinate is easier. So y prime is going to be the a value, which is 1, times the y original, which is 2, plus the d, which is minus 3. So this is going to be 2 minus 3 or negative 1. Now, folks, let's do the same transformation, but using the factored form. Notice, with the factored form, we have the GCF pulled out, and we have 2 sets of parentheses. That tells you you're in factored form. When you're in factored form, you use the b value first and the c value second. Okay, so let's do our new x prime is going to be the x original divided by b, opposite of what you see on c. Okay, so here we're going to say our x prime is going to be the x original, which is 4, divided by our b, which is going to be 2, and then we're going to do the opposite of what we see, and we're going to add 1, and we're going to get 3. Notice that's what we got when we just did the other form, the unfactored form, a few moments ago. For the sake of completeness, let's go ahead and do y prime. Recall y prime is much easier. We're going to do 1 times 2 minus 3 So that's going to be 2 minus 3 equals negative 1. So we get the same exact point using both the factored and unfactored form. Okay. In this next example, we are told that we have a point on the original function f of x of 12 comma 5, and we are asked to find the new point after being transformed on this transformation function. The first thing we notice is that this is in a non-factored form. We have one set of parentheses only. When we are in a non-factored form, we're going to work with the c value first and then the b value. Okay, so let's review. Our x prime, which is our new x, is going to be the x original divided by the b value opposite of the c. But the question is, which of these do you do first? So in this particular problem, because we're in the unfactored form, we're going to work with the c first, then the b. So we're going to take our original x, which is 12. We're going to do the opposite of what we see. We're going to subtract 4. That's going to give us 8. And then we're going to divide by the b value, and we're going to get 4. So our x prime is going to equal 4. Okay, very quickly, the y value, recall, is going to be, or I should say the y prime is going to be the a value times the original y plus the d value. Okay, here our a value is 2, our original y value is 5, that gives us 10, and we're going to subtract 2, and we're going to get 8. So our our y prime point is going to be 8, so the transformed point is going to be 4, comma 8. Let's now do the same problem, but change it to the factored form. Here, in the factored form, we see two sets of parentheses. When we're in the factored form, we're going to work with the b value first and the c value second. Okay, recall x prime is going to be equal to x original divided by b, opposite of what you see with c. Here, we're going to work with the b first. Our x prime is going to equal 12 divided by our b value, which is going to give us 6. Then we're going to do the opposite of what we see here. So we're going to subtract 2, and we're going to get 4. For our y prime, it's going to be our a value, which is 2, times our original y value, which is 10. And then we're going to subtract 2, and we're going to get 8. So if we work with the factored form, again, these are the same exact equations, we're going to get the same exact final answer. Next, we are given an original point 3 comma 4 and f of x, and we're given this new transformation function g of x. Folks, one set of parentheses, unfactored. We're going to work on the c value first and the b value second. Let's take our original x value, which is 3. We're going to do the opposite of what we see. We're going to subtract 6. We're going to get negative 3. Next, we're going to take that b value, negative 3, and divide it. Therefore, our x prime is going to equal 1. Our y prime is going to be this a value, negative 5, times the original y value, which is negative 4. That's going to give us negative 21. And then, negative 20, and then we're going to subtract 1, and we're going to get negative 21. So our transformed point is going to be 1 comma negative 21. Let's go ahead and jump right to the factored form and see if we get the same answer. So the factored form is going to be negative 5f of, we're going to pull out the negative 3, and we're going to have x minus 2 here. And we're going to have the minus 1. Okay? Always double check to make sure that when you distribute, you have the original function. We have negative 3x plus 6. Okay. Since this is in the factored form, since there's two sets of parentheses, or in this case a bracket and a parentheses, we are going to use the b value first and the c value second. So let's do that. Our x prime is going to be the x original, which is 3. We're going to divide by the b value, which is -3. We're going to get -1. Next, we're going to do the opposite of what we see. We see a -2. We're going to add 2. And our final x prime with this factored form is going to be +1. For the y prime, it's the same thing. We're going to do -5 times the original, which is 4. That gives us -20. We're going to subtract 1, and we're going to get -21. So in the factored form, we get the same point. The whole key is you reverse the order that you do things based on whether you are in unfactored form versus factored form.